Question 10. Suppose that 5 grams of silver is initially at 27 degrees Celsius. What is the final temperature of the sample of silver after it has released 0.75 kilojoules of heat? And then they give you the specific heat of silver, which is 0.235 joules per grams Kelvin. Okay, so we need an equation relating the mass of an object and its heat. And we have the perfect equation for that. It's Q equals mc delta T. Or mc T initial, or rather T final minus T initial. That's the same thing as change in temperature. Okay, so they give us 5 grams of silver, so M is 5.00 grams. They give us C. C is 0.235 J per GC. And they also give us initial temperature, so Ti equals 27 Celsius. And my mistake, this was actually in Kelvin. Okay. And finally, they give us Q, which is 0.75 kilojoules. Okay, so we look at our constant here. We have joules per grams times Kelvin. So the grams is going to work in that equation. What about the Celsius? We should probably convert it to Kelvin so that it works with this. And the way you convert to Kelvin is to just add 273. So that's going to equal 300 K. Same with this. This is currently in kilojoules, whereas our constant is in joules. So we're going to want to convert this to joules. Just multiply it by 1,000, and that gives you 750 joules. Okay? So we have our Q, we have our M, or rather, we have our M, we have our C, and we have our Ti. So we just need to solve for T final. So we have Q is 750. Alright, that'll be bigger. Q is 750 equals M is 5, and C is 0.235 times T final minus T initial. So TF minus 300. So that's definitely a calculator problem, but if you multiply it out, you're going to get 750 equals 5 times 0.235 times TF, so 1.175 TF minus 5 times 0.235 times 300, which is 352.5. Add this over to this side, so the next line is going to read 1102.5 equals 1.175 T final. Then divide both sides by 1.175, and you're going to get 938.3 equals T final, which is closest to answer 1 on your test, which says 938 Kelvin.